Hi there. Well, I've just come back from a holiday up in Scotland, and during some of the periods of very heavy rain I ended up browsing some of the model engineering forums on the internet, and I came across a link to a document called the Parker O-Ring Handbook. If you Google that, you'll find a link to a PDF which you can download, and it's a document that contains nearly 400 pages covering O-ring design and application. So I thought I'd have a bit of a read of it, and it got me thinking about this Hoglet engine that I'm currently making. Now, I machined the cylinders to be sort of just slightly smaller than the outside diameter of the O-ring that I'm using, and the O-ring is a BS020 O-ring with an outside diameter of 1.004 of an inch. And I followed the same sort of principle that I followed when I made the Jerry Howell Farm Boy, and the compression, that was fantastic, so I didn't really have any reservations about making the cylinders just marginally smaller. However, it got me thinking, because this document that I downloaded refers to something called squeeze, and that's the amount of squeeze that you apply to the outside of an O-ring, and it's quite complicated, I think, really. But the more squeeze you have, the more friction you'll get and more wear on the O-ring, which is obviously bad. And if you don't have enough squeeze, then obviously you'll have compression issues. So I think in hindsight I maybe should have followed exactly the drawing specification, which defined the internal diameter of the cylinders to be between 1 inch and 1.001 of an inch. But anyway, fingers crossed, I'll be okay. If I find that there's an issue, I think I've got a couple of options that might get me out of the problem. But anyway, we'll see how we get on. But in this video, what I'm going to be doing is machining the cylinder heads for this little Hoglet engine. Well, I think my birthday's come early. I've received a fantastic present in the post from Olivier in France, and Olivier has previously made the nameplates for the Farm Boy and the odds and ends engine, and he's just made me this, and it looks fantastic. So I can't thank you enough. I'm really impressed, but it's certainly put the pressure on me to get this little engine running now, so fingers crossed it'll work at some point. So for the cylinder heads, I've got this lump of cast iron, 70mm in diameter, around about 2.8 inches, and I've cut a couple of pieces off, and these need to be faced on the lathe and reduced to a diameter of 0.813 of an inch. Okay, so what I'm going to do now is I'm going to mark this chuck jaw up here and mark the part. I don't know whether it makes any difference. It's quite an accurate 3-jaw chuck is this, but I'm going to switch the part round now, put it in the same position and face the other edge off until I get to 0.813 of an inch, but I'll do that bit off camera. Okay, so I've just faced this side off. It's still oversize, but I've just measured the width, and the width comes in at 0.863 of an inch, and my target is 0.813, so I'm 50 thou to go on this. So 50 thou equates to 1.27 millimeters. So what I've done is I've locked the carriage, I've zeroed the dial on the compound slide, and I'm going to take the final cuts using the compound slide. So 1.27 millimeters on the compound slide is 1 full turn plus 13.5 increments. So that should get me down to 0.813 spot on. But I'll do that off camera. Well, now I need to reduce the diameter down to 2.5 inches, and I can just manage to machine sort of inside this the jaws of the 3-jaw chuck, and I've set the carriage stop down here, so I'll do all this machining just using the carriage, and fingers crossed it'll work out okay. Well, that's spot on 2.5 inches now, and what I've done is just mark it up again against this chuck jaw. So I'll switch it round in the same position and machine this other side down to 2.5 inches, but I'll do that off camera. Well, that's turned out okay, and the other one's on the mill. So to hold it in the vise I've used a V-block and a couple of parallels and this piece of round bar at the front. And I've put the coax indicator on it. Just fits on there, so I'm happy with that. So now I'm drilling the holes for the valves. So initially I centre drilled and then used a 6mm stub drill. Now I'm using this 21/64 drill to go right through. Once I've done that, I'll ream to 11/32. Looks to be a bit of movement on that drill. Fingers crossed we'll be okay. So while I'm here, I'm just going to have a go at cutting the valve seat. So going by the drawing, I think this needs to be about 30 thou deep. looks alright, I think. So while I'm here, I'll drill the 4 holes for the M4 bolts to go through, but I'll do that bit off camera. So on the 2 internal combustion engines that I've made previously, I've actually cut the valve seats into the valve cages as per the design. But for the Hoglet, the valve seats are actually cut directly into the cylinder head. So what I've done is, once I drilled the holes through here for the valve guides, I then straight away afterwards use this 90-degree countersink to cut the seats. So hopefully it'll turn out okay. And as you can see here, the valve guides only go that far down into the head. Now, to do the rest of the machining, the suggestion is to make a fixture out of a piece of 2" by 2" aluminium. Now, I've not got any 2" by 2" aluminium, but I've got 2" diameter aluminium. So what I've done is I've made this and put some flats on it, and I think I've machined it quite accurately. And the idea is, I don't know whether this is the right way around or not, but to actually slot the head on like that and then bolt it with a couple of bolts. Oops. Like that. So then you can put it in the lathe or the mill and do the rest of the machining. So the hole for the spark plug needs to be drilled 0.813 of an inch from the centre, that distance there, but it's got to be drilled at a 30-degree angle like that. So what I've realised is that these studs here, they were longer, and I couldn't work out why they should be that long, and the reason is you need to put some packing under here, so that when you drill through you're not going to hit the fixture. And just to make sure that I've got the 30-degree angle right, so if I put this angle gauge on here, it's reading round about 0.1 of a degree, or thereabouts, 0.09. If I put that on there, I get 60.1413, so that's pretty close. And there's a double check. I'll put that on there. You can see that that line is pretty much parallel with that one. So I'm happy that that's at 30 degrees. So on the y-axis I've centred using the inside of the jaws, and I've put this wiggler on just to get my position on that mark where I need to start drilling the spark plug hole. And as another check, I've just put this 9mm drill bit in here just to make sure that I'm not going to hit the valve seats, and it looks pretty much spot on to me. I'll just clear them. Okay, so I'm just going to use this 4mm slot drill just to open it up, and then I can use a centre drill. So I'll centre drill off camera, and I'll then drill through with a 6mm drill bit. Well, I centre drilled and then drilled through with a 6mm drill bit, and then this 9mm drill bit. I think it'll go off centre if I try and drill through that. So what I'm going to do is I'm going to open it up very slightly with a 12mm slot drill. Okay, now I'll go through with a 9mm, but I'll do that off camera. So now I need to use a slot drill which will be 22mm in diameter to open up the outside of the spark plug hole, and it needs to be opened up from this edge here down to a depth of 0.675. Well, I've got the big guns out now for this 22mm slot drill. So it's an AR-40 collet chuck. So I cut about 400 RPM. Blimey. Now I've just realised that the tap for the spark plug has got to be an M10 with a 1mm pitch, and I've not got one of those, so I've had to send off for one. But the advantage with this fixture is I can take the head off now, put the other head on and repeat exactly the same process, but I'll do that off camera. Well, the tap finally arrived. So this is the right hand head, and this is where the exhaust port needs to be drilled, and it's 1/2 inch from the front face, and it needs to be a diameter of 1/4 inch, but I'm going to go through with a 6mm stub drill first of all. So I'll drill through with the 1/4 inch drill bit off camera. And the intake is made in a similar manner, but just with a 3/16 of an inch drill bit. So now it's a matter of machining a hole for the exhaust pipe, and that needs to be at a 21° angle. So I've used this little angle gauge I made in a previous video, and the top of the fixture is parallel with the top of that, so I'm happy it's at 21 degrees. Now the depth of this hole needs to be 0.625 of an inch, and when it gets to that depth it needs to be on centre with this hole here. So what I've done was I touched the tool at the top and then zeroed the gauge. Then I've moved the spindle down by 0.625 of an inch, and then I've moved the x-axis to centre on this line here, which is the centre of this hole up here. So having done that, I think the x-axis is spot on, so I just need to sort of drill down to that depth. So I've offered a bit of support with this jack, and I need to drill to a depth of 0.625. So hopefully that's worked out okay. So what I can do is I can just take this head off, put the other one on and repeat the same process, but I'll do that bit off camera. So the intake is machined in a very similar manner to the exhaust using this 3/8 of an inch end mill, again going to a depth of 0.625 of an inch. Once that's done, it needs opening up a little bit more with a larger end mill. So the idea now is to open this top bit up with a 7/16 end mill. Now I've not got a 7/16 end mill, but I've got an 11mm one, so hopefully that'll be okay. And I need to go to a depth of 0.415 of an inch. Well, they're looking pretty good. I've drilled and tapped a couple more holes off camera, and I think all I need to do is put them on the lathe and cut the fins. Well, this is going to take a while. I think these have turned out pretty well. That looks pretty much spot on. Likewise that one. That's pretty much spot on. Very slightly off centre. Don't know how that happened, but I think it'll be okay. That's the exhaust. Well, I must say they took some machining, and it's a good job this fixture was included in the drawings, otherwise I'd have been totally lost, I think. And I think the only bit that I messed up on were the valve seats. I think, looking at the drawing again, I think I should have cut the valve seats to a depth of 10 thou, and I cut them to a depth of 30 thou. But I think they'll be alright. But apart from that, this engine is coming along nicely. So I hope you liked the video, and I hope to see you later.